In question 1, we are presented with a spinner that contains 12 sectors. 5 sectors are labelled with €6, 3 sectors are labelled with €9, and the rest are labelled with €0. In a game, a player spins the wheel and wins the amount of money that the arrow lands on. In part A, we are told that Fiona plays the game a number of times. We need to find the probability that she gets a €6, then a €9, then a €6 the first 3 times she plays. 5 out of the 12 regions are labelled with €6, so on an individual spin, the probability you get €6 is 5 over 12. 3 out of the 12 regions are labelled €9, so on an individual spin, the probability you get €9 would be 3 over 12. In this question, we need 3 things to happen. We need €6 on the first spin, €9 on the second spin, and €6 on the third spin. We can find the probabilities of each of these events individually. There's a 5 out of 12 chance to get €6 on the first spin, 3 out of 12 to get €9 on the second spin, and 5 out of 12 to get €6 on the third spin. In probability, the word "and" typically corresponds to multiplication. So here, we need to multiply together the 3 individual probabilities. This comes out as 25 over 576. When we write this as a decimal rounded to 4 decimal places, we get 0.0434. In part B, we're told that Rowan also plays the game a number of times. We need to find the probability that he gets €9 for the 3rd time on the 8th time that he plays. Well, there's 2 things that need to happen here. Rowan must win €9 exactly twice in the first 7 spins, and then win €9 on the 8th spin. On the previous page, we showed that there was a 3 out of 12 chance of winning €9 on any individual spin. So the probability of getting €9 on the 8th spin would be 3 over 12. The probability of getting €9 exactly twice in the first 7 spins is a bit harder. Here, we'll have to use the binomial distribution formula. N choose R times P to the R times Q to the N minus R. Here, N refers to the total number of trials. Since we have 7 spins, N is equal to 7. R is the amount of times we want our event to happen. Since we want €9 exactly twice, we will have R equal to 2. P is the probability that your event occurs on an individual trial. Here, there's a 3 over 12 chance we get €9 on an individual spin. So P is 3 over 12. Q is the probability that your event does not occur on an individual trial. We'll always have Q equal to 1 minus P. Here, Q is equal to 1 minus 3 over 12, which is 9 over 12. So, after subbing in, we get 7 choose 2 times 3 over 12 to the power of 2 times 9 over 12 to the power of 7 minus 2. When we type this into our calculator, we get 5103 over 16384. The word "and" corresponds to multiplication, so to get our final answer, we must multiply this by the 3 over 12 we obtained earlier. Rounded to 4 decimal places, this gives us an answer of 0.0779. In Part C, we're told that Olga plays the game 2 times. We need to find the probability that Olga gets less than €16 in total. Well, when we think about the structure of the game, it's quite difficult to win at least €16 when you play the game twice. On each individual spin, you'll either earn €9, €6 or €0. The only way that you could end up with more than €16 is if you got €9 both times. A 9 and a 6 would give you €15, which isn't enough. So, the only way to get at least €16 is to get €9 on the first spin and €9 on the second spin. There's a 3 out of 12 chance to get €9 on an individual spin, so the probability here comes out as 3 over 12 times 3 over 12, which is 1 over 16. This is the probability of getting €16 or more in your first 2 spins. To find the probability that we get less than €16, we simply have to subtract this number from 1. This gives us 1 minus 1 over 16, which is 15 over 16. Written as a decimal with 4 decimal places, this comes out as 0.9375.